In this first video for what is it, 1B1, we're going to talk about some definitions. So take out your proof sheet, the wording for proofs, and I just want to go through some definitions of triangles. You should have seen definitions for these types of triangles before, but I want to specify exactly what we mean when we say right triangle, acute triangle, and so on. So in geometry, the definition for a right triangle is if we have a right triangle, then that triangle has a right angle, and we can abbreviate it with if right triangle, then right angle. So if there's a triangle with one right angle, then it's a right triangle. The converse is also true. So, if triangle with right angle, then right triangle. For an acute triangle, we've talked about acute angles. An acute triangle will have 3 acute angles. So if there's an acute triangle, then that triangle has 3 acute angles. And the converse is also true. If we have a triangle with 3 acute angles, then that triangle is an acute triangle. So an acute triangle has 3 acute angles. A right triangle has 1 right angle. And an obtuse triangle just has 1 obtuse angle. It's not possible for it to have more than 1. So if obtuse triangle, then obtuse angle. And the converse, if triangle with obtuse angle, then obtuse triangle. So we're talking about angle measures here. So right angle, it's a right triangle. 3 acute angles, it's an acute triangle. 1 obtuse angle is an obtuse triangle. And then we have an equiangular triangle. So equiangular, equi would mean equal, angular, angle. So equal angles pretty much gives us the definition. So if equiangular triangle, then 3 congruent angles. And the converse is also true. If triangle with 3 congruent angles, then equiangular triangle. So these are all ways to classify a triangle by its angle measure. So let's group these together. These are all angle measure. Now we'll move on to classifying by its side length. So there's another way we can classify triangles. Classify by its angle measure and side length. So if we have a scaling triangle, that would be a triangle with no congruent sides. So then, no congruent sides. Converse again is also true. If triangle with no congruent sides, then scaling triangle. An isosceles triangle would be a triangle that has at least 2 congruent sides. So if isosceles triangle, then at least 2 congruent sides. And the converse is also true. If you have a triangle that has at least 2 congruent sides, then it's an isosceles triangle. So if triangle with at least 2 congruent sides, then isosceles triangle. And finally, if you flip to the back, there's a third way to classify a triangle by its side length, and that would be if it's equilateral. So equiangular and equilateral are similar. Equi still means same. Lateral, we'll talk about the side lengths. So equal side lengths or congruent sides. So if equilateral triangle, then 3 congruent sides. And the converse is also true. If triangle with 3 congruent sides, then equilateral triangle. And then finally, we have a regular polygon, which combines both classifying something by its side length and angle measures. A regular polygon is a polygon that is both equiangular and equilateral, meaning all of its sides are congruent and all of its angles are also congruent. So, if regular polygon, then equiangular and equilateral. The converse is also true. If equiangular and equilateral, then regular polygon. Okay, so if we flip back to the front, we had our first chunk of definitions was for angle measure. Now we can classify it by side length. And that continues on to the back, so this would also be a classification of side length here. So side length. And then we'll continue on with more for this proof sheet later.